In this video, we will try to find the exact value of quadrantal angles. Now, before we do that, we should really learn what a quadrantal angle really is. So a quadrantal angle is an angle where its terminal arm will lie on the x or y axis. And in order to find the exact value of these angles, it's going to be very helpful if we were to draw the unit circle. Okay, because the unit circles will well, from before, it's pretty clear that the unit circle is capable of giving us quite a bit of information about the ratios. Okay, so the tricky part is drawing the unit circle. Okay, you know what? We'll live with that. All right. Now, because it's a unit circle, what I'm going to do is I'm going to write the coordinates of these x and y intercepts of the unit circle. So here we're looking at 1, 0. This is 0, 1, negative 1, 0. And lastly, we have 0, negative 1. And just to refresh our memory, we know that sine theta is defined as y coordinate of the unit circle. Okay, you can think of it as y over r, and r being 1 if you want. But anyways, sine theta is equal to y, cos theta is x, and tan theta is y over x. Okay, so hey, you know what? I think we can do this. So if we have an angle of 0 degrees, which is a quadrantal angle because its terminal arm is on the positive x-axis, right? What's sine of 0 degrees? Well, what's the y coordinate of the point on the unit circle? It's 0. So sine 0 degrees is 0. And cos 0 degrees is 1 because the x coordinate's 1. And tan 0 degrees is 0 over 1, which is 0. So if I'm trying to find out sine, cos, or tan of 90 degrees, I look at this point. If I'm looking at an angle of 180 degrees, I look at this point. 270 degrees, I look at this point. So, you know, I'm going to give you some time to try to fill in this table yourself. And then, so pause the video and try to do it yourself, and hopefully your ratios match up with mine. Okay, so sine 90 degrees, we're looking at 1. Cosine 180 is 0, 270, negative 1. So this last row here for 360 degrees is coterminal to 0. So these ratios will correspond to these three ratios, right? Has to be 0, 1, 0. Cosine 90, we're looking at 0, cos 180, cos 270. All right, tan 90, be careful. Tan 90 is 1 over 0, which is undefined. So those bring back memories from grade 9, right? Undefined, like the slope of a vertical line. Tan 180 degrees is 0, and 270, tan 270 is undefined as well. Perfect. So that's how you find the exact value of quadrantal angles. For these 6 examples, if you look at the angles you're working with, these are not as friendly because none of them are between 0 and 360 degrees, but not a problem. What we're going to do is find the angle which is coterminal to, for example, negative 270 degrees and also lies between 0 and 360. So in order to do so, in this case, you add by 360 degrees. But for all of these, you either add or subtract by a multiple of 360 degrees, and they'll bring you back to a value between 0 and 360. All right, so here, this add by 360, you'll get sine 90. Sine 90 degrees, so if you can't imagine the unit circle, then you can quickly draw it out and study where the terminal arm is going to be. 90 degrees means that the terminal arm will be on the positive y-axis, which means that the y coordinate is 1. So this Coterminal to 720 is 0. Tan 0 is 0 degrees. I'm studying the positive x-axis when I'm asking myself what tan 0 degrees is. Cos 540, subtract by 360, that's 180. So if I'm rotating 180 degrees, I'm looking at the negative x-axis, which means cosine is -1. Cosine 180 degrees is -1. Tan 540, hey, that's 540 degrees, which means we're studying tan 180 degrees, and that means the we're looking at the negative x-axis again, so that's 0. Sine 450, what's coterminal to 450? And between 0 and 360 degrees, 90. Positive y-axis, we're looking at 1. Cosine -180, coterminal to that is 180 degrees. So we're looking at the negative x-axis again, -1. Okay, and you know what? If you have a calculator, you can check any 6 of these. So I don't know, let's say cosine -180. Hey, what do you know? Let's do one more. Tan 540. Perfect. Okay, so refer to the unit circle if you're ever in doubt for finding exact value of quadrantal angles.